Hi there. So this lecture will be used to go through more examples on using the u-substitution method that we couldn't cover in the previous lecture. Okay, so let's get started with these examples. Number one, we have the integral of x over the square root of 1 minus 4x squared, okay, dx. Okay, so like I mentioned in the previous lesson, what we are looking for is some inner function that makes our integral complicated. So in this case, we can see that we've got 1 minus 4x squared underneath the square root, and that is making this pretty complicated. Okay, now it seems a bit vague talking about what is complicated and not. And that's why I said in the previous lecture that you have to do lots and lots and lots of examples so that spotting this complicated part becomes easier over time. Okay, so please do all the tutorial questions, the questions in the notes, and the questions in the extra notes. Okay, the more practice you can get, the better. Okay, so in this case, the complicated bit is 1 minus 4x squared. So we are going to say u is equal to 1 minus 4x squared. This is going to tell us how to change from x variables to u variables. Now, we can use this to change the function from x to u, but remember, we also need to change the differential. So we have dx as our differential, but what we really want now is du. So du will then be given by du by dx. So let's find the derivative. We're going to get minus 8x dx. Okay, but notice here in the du differential, we've got minus 8x dx. But in our original expression, notice how we only have x dx. Okay, this minus 8 does not appear. So what we need to do is a little bit more manipulation to get this looking like what we have. So if we take this minus 8 over to the other side, we're going to get minus 1/8 du is equal to x dx. And now this x dx does appear in our original expression, which is good. So with this in mind, let's rewrite the integral in terms of u. Okay, so x dx is going to be replaced with minus 1/8 du. So we're going to have minus 1/8 and then du at the end. Then 1 over the square root of 1 minus 4x squared is going to be replaced with 1 over the square root of u. Okay, so let's just put this in red here. This x dx becomes minus 1/8 du. And because of our u substitution, 1 over the square root of 1 minus 4x squared becomes 1 over u. Okay, so this is the color coding that I've used here. Okay, so now, as you can see, this is much simpler than what we had before. So we can rewrite this as minus 1/8, the integral of u to the minus 1/2 du. And now this is a simple application of the power rule. So what we're going to do is add 1 to the exponent to make it 1/2, divide by 1/2, but that's the same thing as multiplying by 2. So we're going to get minus 2 over 8 u to the 1/2, and don't forget the plus c. Okay, we can simplify this a bit more. So we're going to get minus 1/4 u to the 1/2 plus c, but we're not done yet because we don't want u. So we don't want u, we want x. So this u variable needs to be replaced with x. How do we do that? Well, u is equal to 1 minus 4x squared. So let's just substitute that directly. So we're going to have minus 1/4 What is u? U is 1 minus 4x squared to the half plus c. So we see that everything is now in terms of x, which is exactly what we wanted. Okay, let's have a look at another example. So this is example number 2. We have the integral of cos 5x dx. And again, spotting what is making this complicated comes with practice. But we can see that cos is a simple function. We know how to deal with that. But we've got this inside function 5x. That is making our lives a bit more difficult. So what do? We let u be this inside function. So u is equal to 5x. So that is how we are going to go from x variables to u variables. But we also need to change the dx differential to become a du differential. Well, we've got u as a function of x, so we can use that to find du. So du is going to be du by dx. So du will then be 5 dx. Okay, but let's look at our original integral. Here we only have dx. Here we have 5 dx. That's a problem. We don't have 5 in the original integral. So we're going to have to take this 5 over to the other side. So this is going to become 1/5 du is equal to dx, which is what we have. So we do have dx by itself. So let's substitute this into what we have. So the integral of cos 5x is now going to become cos of u. Dx is now going to become 1/5 du. Yeah, so now we can take the 1/5 out to the front. So we have 1/5, the integral cos of u du. Now this can be integrated very easily. The integral of cos is going to be sine. So we are going to have 1/5 sine of u plus c. But remember, we don't want u. We want x. So we need to replace this u variable with the original x expression. What was that? U is equal to 5x. So we can write this as 1/5 sine of 5x plus c. Yeah, and that's our final answer. So you see, it's very simple. We look for the inner function that is causing us trouble. In this case, it's 5x. So we let u be equal to 5x. That is how we go from x to u. But remember, with integrals, we also have the differential to worry about. The old differential was dx. We want the new differential du. How do we do that? Well, we are given the function u is equal to 5x. We then use this formula here to find du. Du is equal to du by dx times dx. Du by dx in this case is the derivative of 5x. That's going to be 5. But notice how 5 dx does not appear in our original integral. The original integral only has dx. So what we need to do is take this 5 over to the other side. So we get 1/5 du is equal to dx, which is what we can use to replace dx. Now we are left with 1/5 the integral cos of u du. That can be easily integrated to give us 1/5 sine of u. Don't forget the plus c. but we don't want u, we want x. So we need to replace x. So u is replaced with 5x, which is what we started with way back at the beginning. Okay, so we get our final answer in terms of x. Okay, let's take a look at another example. Okay, this is example number 3. Okay, so now we have the integral of the square root of 1 plus x squared times x to the 5 dx. Okay, and we're going to repeat the same procedure as before. So we look for the inner function that's causing us trouble. That's going to be this 1 plus x squared. Okay, it's causing us trouble, so we say u is equal to 1 plus x squared. Next, we need to find the differential du. Du is equal to 2x dx. Now, look back at our original integral. The leftover part is x to the 5 dx. It's not 2x dx. So we have to do a little bit more work. So first, let's take the 2 over to the other side. So we're going to have 1/2 du is equal to x dx. Now, we have x to the 5 in the original integral. So we have x to the 5 dx. What we have so far is x dx. That's not going to help us. So we need some way of multiplying by x to the 4. How do we do that? Well, we use our original expression in terms of u. So let's take a look at that. U is equal to 1 plus x squared. So that means u minus 1 is equal to x squared. This also means that u minus 1 squared is equal to x to the 4, which is what we need. So let's multiply both sides of our differential equation here by x to the 4. So on the left-hand side, I'm going to multiply by u minus 1 squared. And on the right-hand side, I'm going to multiply by x to the 4. Notice that the right-hand side now becomes x to the 5. This is exactly what we needed to replace this part of our original integral. So let's now do the replacement. So we have the integral. The square root of 1 plus x squared is now going to become the square root of u. X to the 5 dx is going to be replaced with 1/2 u minus 1 squared, u minus 1 squared du. Okay, so I've replaced the square root of 1 minus x squared with the square root of u. So that becomes that. And I have replaced x to the 5 dx with 1/2 u minus 1 all squared du. Those are the two things that I calculated on this right-hand side. So now we've got a new integral to calculate. So this becomes the integral of the square root of u times 1/2 u minus 1 squared du. Okay, now this looks a bit complicated, but it's nothing more difficult than what we've had before. So let's expand this out so we get the sum of terms with different powers. So we're going to have 1/2 the integral. We can replace the square root of u with u to the 1/2. U minus 1 squared will be u squared minus 2u plus 1 du. Okay, so we've expanded out the square. So let's now multiply in u to the 1/2. So we multiply that into all our terms. So this will be 1/2 the integral of 1/2 plus 2. That's going to be u to the 5/2. Minus 2, 1/2 plus 1, we're going to get u to the 3/2. And finally, u to the 1/2 times 1, that's just going to be u to the 1/2. So now we see we have simple powers over here, and we can use the power rule for antiderivatives. So let's do that. So we are going to get 1/2. The antiderivative of u to the 5/2, we need to add 1 to the exponent to make it 7/2, and then divide by that, so we get 2/7, u to the 7/2, minus 2 times. We're going to add 1 to the exponent, so this will become u to the 5/2, but we need to divide by that, so we get 2/5 u to the 5/2. And lastly, we add 1 to the exponent to make it 3/2. Divide by that, we're going to get 2/3 u to the 3/2. And don't forget your plus c. Okay, so now we've done our integral in terms of u. Remember, we need to go back to x. Need to go back to x. So wherever we see a u, we need to replace it with 1 plus x squared, because that is what we had over here. Okay, so wherever we have a u, we replace it with 1 plus x squared, because that's what we defined right at the beginning. So multiplying everything out and doing the replacement, we are going to get 1/7, 1 plus x squared to the 7/2, minus 2/5, 1 plus x squared to the 5/2, plus 1/3, 1 plus x squared to the 3/2, plus c. Okay, so what did I do here? I multiplied through by 1/2, as you can see, and then wherever there was a u, I then replaced it with 1 plus x squared, because that is the definition we made right at the beginning. We said u was equal to 1 plus x squared. Okay, so then this gives us our final answer. Okay, and as always, if you have any questions about any of this, please let me know through the WhatsApp group or through email. You can send it whenever you need help. Okay, let's look at one more example here. So this is example number 4. Okay, so we have the integral 1/3 minus 5x, all of that squared, dx. Again, what is causing us problems? It's this inside part, 3 minus 5x. Okay, we want to try get rid of that or make it simpler. So we let u be equal to this complicated part that's making our life difficult. So that's going to be u is equal to 3 minus 5x. So again, that's how we go from x variables to u variables. But we also need to change the dx differential to become a du differential. So let's do that. How do we find du? Du is equal to du by dx dx. So du is equal to the derivative of u with respect to x. That's going to be minus 5. And then don't forget the dx. Okay, let's look at our original integral. Notice how we only have a dx. We do not have a minus 5 dx. That does not appear in the original integral. So how do we fix that? We take this minus 5 and we take it to the other side. So minus 1/5 du is equal to dx, which is what we have over here. Okay, so we have everything we need to convert this x integral into a u integral. So let's do that. This is equal to 1 over 3 minus 5x, all of that squared, is now going to become 1 over u squared. I have replaced 3 minus 5x with u. That is exactly what we said at the top here. dx, that gets replaced with minus 1/5 du. Minus 1/5 du. It is just a replacement. You don't have to do much thinking. You just look, before we have 3 minus 5x, we replace that with u. dx, we replace that with minus 1/5 du. It's just a replacement. Now, with a bit of work, we can reorganize this to minus 1/5, the integral u to the minus 2 du. So we had a u squared at the bottom. If we take that to the top, the exponent becomes negative. So how do we integrate this? We add 1 to the exponent and divide. So we have minus 1/5. Add 1 to the exponent. That's going to make the new exponent minus 1. We divide by minus 1, so we get a minus. Minus u to the minus 1. Okay, and don't forget plus c. So now the minus and the minus, they're going to cancel. So we're going to get 1/5 times 1 over u plus c. Good. But we don't want u, we want x. So wherever we have a u, we are going to replace it with 3 minus 5x. So let's do that. So this is now going to become 1/5 times 1 over 3 minus 5x plus c. And we can leave it like that. Okay, so again, not very complicated. Let's just run through this one more time. We have this integral. In the denominator, we have something complicated. What is making it complicated? The 3 minus 5x. That is making this complicated. So the first thing we do is we let u be equal to 3 minus 5x. Good. Now we need to find du. That is step 2. du is equal to the derivative of u with respect to x times dx. What is the derivative with respect to x? That's going to be minus 5. But if we look back at our original expression, there is no minus 5 dx. We only have dx. So we need to take this minus 5 and move it to the other side. So we get minus 1/5 du is equal to dx. Now dx is by itself, which is exactly what we had in the original integral. So we are going to take part 1 and part 2 from step 1 and step 2, and we're going to substitute that into our integral. So 3 minus 5x, that now becomes u. So from 3 minus 5x, we now put u. dx now becomes minus 1/5 du. That is exactly what we just had here. So we're using this part and this part to substitute. Next, this just becomes a simple integral in terms of u. So this part here is very simple to do. So we perform the integral, we get 1/5 times 1 over u plus c. But remember, we don't want things in terms of u, we want our original x variable. So we have u, remember that u is equal to 3 minus 5x. That's what we said right at the beginning. So we are going to take this and replace u. So we get 1/5 times 1 over 3 minus 5x plus c. Okay, and this is our integral in terms of x, which is what we wanted. Okay, so I think that's enough examples for now. We will carry on not tomorrow, not on Wednesday, because that is the tutorial and tutorial test. We will carry on Thursday and on Friday. Okay, and again, if you have any questions, please post them on the WhatsApp group. I will have a look, or if you can email me your questions, I'll have a look there as well. Okay, but please remember with this u substitution, it requires lots and lots of practice. Okay, it's not easy spotting which parts need to become u. That comes with practice. So you have to do the tutorials, you have to do the exercises in the notes, and you have to do the exercises in those extra notes that are uploaded. Okay, so there's 3 sources for problems, and there's plenty of problems in the textbook as well. So please go through as much as possible because this is a very, very important integration technique that we will be using for the rest of the module. Okay. And as always, please email me if you have any issues or WhatsApp me if you have any issues. Okay, and I'll see you tomorrow for the tutorial test. Bye, everyone.